All right, today is June 21, 2023. This is the meeting of the Kubernetes Storage Special Interest Community. On the agenda today, we've got two items. One is modify volumes for quality of service, and the second is change block tracking RPC spec. I think Sunny is not here, so I'm going to move this to the bottom. And it looks like we have Carl, Prasad, and Ivan for the first topic. I will go ahead and hand it off to you, Carl.
Thanks.
Feel free to share screen. I'll stop here and take notes.
Okay. All right, I get host to disable screen sharing. Let me try again.
Oh, let's give you permission. Hang on. All right, go for it now. I think you should be able to share.
Okay. Let me see. Share screen first. Okay, can you see my screen?
Yes.
Okay.
Yep.
So we'll briefly go over what we agreed upon in the working group, the DPG working group. And this is a culmination of two other efforts, right? Previous efforts which went through issues with first overloading too much data in etcd. Then I think the next iteration went through overloading the Kubernetes API server, right? So this iteration, right, the primary goal is to address, scalability of Kubernetes when recovering change block metadata, and to also, fit within the CSI spec definitions, pretty much how it is today. And another aspect which came in because of this, at least the scalability aspect, was we are aiming to be no less secure than the Kubernetes API. We won't guarantee more secure, but essentially what we're saying is that we rely on the Kubernetes API for security, and so we cannot be any better than that with respect to whatever we're proposing. Secondary, right, but important goals, right? We want to make sure there's idempotency in what we're presenting, because there's a session creation aspect to this thing. We want flexibility for the implementers. We got feedback from some of the vendors who participated on this. And we want to make sure that, okay, this is security related. We are not trying to reinvent the wheel with respect to security. We're relying on the Kubernetes API functionality. We don't want to be in the business of maintaining a security model, right, with if we try to invent our own security infrastructure. So let's go on to the proposed extensions. So essentially, we are proposing a new service to the CSI spec. This service will return snapshot metadata. And tentatively, we have two RPC calls here. The first is get allocated. Get allocated essentially is used to return the metadata on the allocated blocks of a single snapshot. That's typically used by a backup application on, say, a first backup of a snapshot. And the second RPC is get delta, which will return the change blocks between two snapshots. We could coalesce this all into a single get delta, and with no secondary snapshot, etc. Those are minor issues, but they're pretty much the same under the covers. So this slideware does not talk about capability flags and other things, but obviously they have to exist to advertise that this service is present. Just a note at this point, we're not going to get into this, but there could be a companion data block service alongside the snapshot metadata service that could be defined so that you could fetch the snapshot data blocks through an API. As it stands with the implementation, one would have to create a volume from the snapshot and then use and mount it as a block device and then seek to the right positions and read the blocks out. That's kind of understood behind this proposal. In the get delta call, right, I'll look at that first because that's the more complex one. So essentially the request contains information on metadata information on the volume and snapshot. We can iron out issues whether volume ID is really needed or not, but it at least gives options to the vendor. There's an opaque session token, and we'll talk about that later on. This session token is actually critical for the Kubernetes implementation part of it, right? It probably has nothing for the vendor side of it. The base, there's a base snapshot, a target snapshot. These identify the two things from which we're computing the difference. And other types of methods like, properties like starting byte offset in case we are continuing from a failed transaction, and max results, right? How many results do you want back in each stream block? The RPC returns a stream of get delta response objects. And this data structure essentially kind of tries to satisfy two worlds: the world of vendors with fixed length blocks and the world of vendors with extent-based systems. I think backup software doesn't care either way, right? Both work. But the idea is that there are definitely, we've observed from some of the, I think from the first iteration itself, we observed there's a spectrum of implementation across vendors, and this kind of matches that. So these are the RPCs. This get allocated is identical to the previous one, except it's only one snapshot over here. So these are the RPCs. One thing to note in both of these, right, call out explicitly that the parameters here are expressed in the server's nomenclature. And the reason for this, we see in the subsequent slides, is because we'll actually use this RPC directly from the application too, but we're talking in the Kubernetes domain then, and then we switch to the service provider's domain. So let's go on to this. This slide is very detailed, and we'll get into zoom in versions of the slide. So, but this is just illustrating the overall picture for people, and we'll get into details and clarify a lot of stuff later. So the first thing to note from this slide is that there are distinctly colored areas, the green and the yellow and the gray. These kind of reflect different security domains in which the solution is talking about. So first, let's talk about the actors involved over here. So we have the backup client who wants to back up something. We have the Kubernetes API server, whose one of our goals is to not overload. Then we have the CSI drivers. The CSI driver, in this particular case, the CSI driver will contribute, what we're proposing will contribute a snapshot session service. And we, the community, will provide a sidecar to that service to interface that service to the Kubernetes side. And behind that sidecar, to support that sidecar, we'll have this other component, which is what we're calling loosely a snapshot session manager, which will manage the proposed implementation. So the implementation consists of two phases. The first phase, we create a session, quote unquote, where we establish the authority of the caller to create the session, and that the caller has access to the snapshots they are specifying. That's crucial. Then the second part, this is where we diverge dramatically from earlier iterations. In the second part, we will allow the we require the backup client to directly use the gRPC to talk to the sidecar. And in that manner, we are bypassing the Kubernetes API and therefore not subjecting it to the load which we were critiqued on in the previous iteration. So let me go ahead and look at this stuff. So looking at the components in turn, so there's an independent manager which provides a session access controller, a session access CR controller. This manager is independent of the CSI drivers because there could be multiple CSI drivers implementing such a snapshot session on a given cluster, and this one will support them all. illustrate for the security model perspective, we're showing all these things in independent namespaces just to show that the security model can encompass these distinct namespaces. Vendor can, of course, collapse them all into one namespace without breaking anything. The CSI session service, this is what the storage provider will provide. And we have a sidecar attached to that, which the community will provide to interact, to plug, to bridge the Kubernetes domain to the SP domain. The session sidecar service, right, will be, which was provided by the CSI driver, will be advertised to the manager through a very simple CR. Actually, it's namespace right now in this proposal, but we debated in the committee and in the working group, and we probably can be non-name global too. I didn't update the slides yet. So this one, essentially the manager can just search for this particular CR and find all the drivers who claim to provide this session service. So the way it works is a backup client will create a snapshot session access CR in the snapshot namespace. Now, the backup client, right, would probably exist in its own namespace, but has access to backup an application. And so the application's snapshots obviously sit in the application's namespace. The backup client has access over there. But that access, right, has to be checked by the system. So, obviously we can't allow any application to look at snapshots in a namespace they don't have access to. So we will check all that over here with these other components. I'll get to that in the next slide. So, but overall, what the manager then does is it creates the session access CR. And as part of doing that, it will actually create another CR and put this CR with the data of the session. This is called a CSI snapshot session data of CR, and put this data in the CSI driver's namespace for this sidecar to find later. Then the backup client will use the CSI API to recover the data. And how does it do it? It does it because this session access CR provides the security information required for the backup client to connect to the sidecar. See, the thing is we need trust going both ways, right? And so we'll work through some of the trust issues later on, but essentially this model allows us for the client to trust the sidecar. It doesn't allow the sidecar to trust the client yet, but that is where where that opaque session token comes in. The opaque session token essentially identifies this object here. And this object is protected from anybody who does not have authorized access, right? So it's opaque to anyone. So where the name is opaque outside. The backup client has that name, and the backup client will provide that name in the call over here. And then with that name, the session's CSI driver sidecar will look up that object and find out all the information which that client is allowed to access, and will then handle the will proxy that call to the SP's session service. That's the overall flow from a higher level. Any questions on this? Okay. So just to go briefly over the security model of the protection for the CRs. So in our security model, we think of it in terms of three roles. There is a client cluster role, a client snapshot session client cluster role, which is going to be allocated to the backup client, right? Globally, it's with the cluster role binding, and that allows the backup client to create the session object in any namespace, and the client also needs to have access to view the snapshots in this application namespace. There's the session manager cluster role. The session manager cluster role essentially grants the service account for the session manager permissions in any namespace to do whatever it wants with the session access object, as well as to some restricted permissions on the session, create the session data object and some restricted permissions looking at the session service objects, etc. And there's the snapshot session service cluster role, which is actually to be applied with a role binding in the CSI driver namespace. And that will give the CSI driver's snapshot session service access to its own session data objects and its own snapshot session service objects, but not to these objects in another CSI driver, which sits in another namespace. That's the security model we're proposing over here. Oh, by the way, incidentally, we have prototyped this. Okay, so at some point, if time permitting, we could go through that if anyone's interested. Okay, so let's talk about the first part, which is the set up the session. First of all, we need to note that the sidecar, the SP, the service provider, the vendor is not involved. It's just purely a function of this community provided session manager namespace. It's nothing to do with the spec per se, right? The CSI spec, but it's setting up things so that in Kubernetes, we can then use the spec. So the way it works is the client creates a session access CR. This session access, and then the client turns around and polls for the result. The session access CR is, first of all, there's a webhook involved, a validating webhook, which will look at the parameters. First of all, it authorizes the client to create this CR, and it then looks at the payload within the CR, which identifies the snapshots in that namespace, which the session is going to access, and it will authorize access to these snapshots. After that, the CR controller gets access, and it will at this point look at the snapshots, and from the snapshots, find the CSI driver name by looking up the volume snapshot content, etc. It'll find the driver involved. Then it will do a search for a sidecar set, right, which has this driver from this driver. So essentially, it's a pretty efficient label search. It'll look for this driver name. If it finds such a sidecar, then it will create this session data object. Right, this is in the CSI driver's namespace, and it will put all the data required, the translated data actually, the data coming in from the application, of course, is all in with using Kubernetes nouns. It will extract the. Go ahead. Okay.
My apologies. Sorry, I wasn't on mute.
No problem. Yeah. It will extract the Kubernetes, it will map the Kubernetes names to the service provider names, and it will write all this data out with the translated mappings over there. And this is just put into the session data object. This session data object, recall, is protected from access by the client and any other ordinary Kubernetes user. Only the CSI driver and the manager can access this. When this is done, right, the result is returned back to the client. The result contains within it the CA certificate of the sidecar, an address to connect to it, right, and a session token, and the session token being the name of this session data object, which can be pretty large and random. So that's how we set up session flow. You notice that, again, there is no service provider vendor involvement in this setup. Okay, so now we come to how does this actually work? So at this point, we start off with, here's the result of setting up the session. So we have a setup CR result with the session token, a service URL, and a CA certificate. And we have this object set up over here with the session data CR, with the Kubernetes IDs mapped to the SP IDs, and this object sits in the CSI driver namespace and protected by that. So first thing to be done is that the client now switches to using gRPC. Up to this point, the client was talking Kubernetes API. Now the client is going to talk gRPC. And the first thing they do is trust the service certificate, which they've got out of this object. that will allow
And just
the
to be clear, that CA cert is like living in a secret or something, or it's a reference?
it's a public certificate, so there's no secret per se.
Got
It's not a reference. It's actually how it gets to the in that result is it's copied out of here, out of the vendors with advertised or registered sidecar.
Got it. Okay.
Yeah, it's not secret information. It's public information. So but what this does though is that the backup client, right, establishes this so that it can trust that the network URL it's going to connect to, right, belongs to something which is supposed to be the right server. That's what it's about. So it gives one-way authentication at this point. So at this point now, the client uses the Kubernetes IDs and makes a TLS gRPC call to the sidecar. gRPC, right, has this TLS and MTLS, mutual authentication. So this is not MTLS. This is one-way authentication. So as far as the client's concerned at this point, it trusts the result coming out of here because Kubernetes, this result was protected by Kubernetes, right? And so it can trust the contents. Now it makes a call over here. Now this call is bypassing the Kubernetes API totally. So this is, I think, is unprecedented. I don't know enough about Kubernetes over its lifetime to know whether it's really unprecedented, but given current, it's not using the Kubernetes API at this point. That's for certain. So when the sidecar, which was listening on that address, the sidecar gets this call. The sidecar now doesn't know who this client coming in is. So what the sidecar does is it tries to, using this opaque session token, it looks for an object with that name in its namespace, whatever namespace it advertised, it's running it. This object could only have been created as a result of the manager having done something. So if there is such an object, right, then the session sidecar will trust that the client is valid. Okay. We had to do this because at this point, we don't have access to any of the Kubernetes. We're not using the Kubernetes API. We don't have access to the Kubernetes. We cannot make a Kubernetes SAR call, for example, because we don't have all the parameters involved. And we definitely do not want to, reproduce or try to reproduce the security model. It's just way too complex and to maintain over time. But this works as well. Because by transitive closure, right, these guys are protected by the Kubernetes API. Okay, so the sidecar gets these things out, and now the sidecar retrieves this object, and it actually then will look at the RPC call and make sure that every one of the objects mentioned in this RPC call, was mentioned in the session setup. Right? And it'll validate that and fail, of course, if it's not. Then the sidecar will translate the, using this data here, will translate the Kubernetes IDs to the SP IDs and make the same call to the SP session service, right? But this time using the SP's IDs. And then essentially it just the streaming happens, so it intercepts the stream and sends the result back to the client. That's more or less what happens. The manager is responsible for other things, right, including maintaining the life cycle of this data or this session by deleting this object when its expiry time has reached. Right, the session sidecar will also validate the expiry time. Stuff like that will happen. We haven't focused on that. Pretty much that is the presentation.
Hey, Carl, the ID translation you just referred to.
Yes.
How does it work? Where's the manager or the sidecar look up the correct information? Is it just in an object and it's a straightforward lookup?
Yes, it is.
Okay.
What happens?
So it's similar to converting a PVC name to a PV name to a volume handle kind of a translation.
Yes, okay. Right. The thing though is it has to be done at session setup time because the CSI sidecar, the sidecar doesn't have runtime permissions to look up all those objects in Kubernetes namespace.
It doesn't?
No, because it's sitting, okay, if you go back to the big picture, right? The sidecar sits over here, unless the vendor configures this stuff to give this guy this namespace or this service account for running the site snapshot access to all PDCs, right? And all snapshots. It doesn't have to have permission. It's not
okay. Well, so this might be unnecessarily complex then, because the way we do it with normal sidecars is, of course, the sidecars have access to all the PDCs and all the PVs.
You can certainly deploy it that way. Yeah.
Yeah. I don't think we want to go over the top on extra levels of indirection for security's sake, if there's not a good reason to. And the existing CSI sidecar model suggests that it's community maintained code. We have a recommendation about the level of permissions you install it with, and namespacing suggestions to the extent that anything is namespaced, and we haven't had problems with that model, I don't think. So we should be able to follow the security model for the existing sidecars and treat this similarly. Okay. As long as there's mechanisms for like multiplexing, multiple implementations in a single cluster, which CSI already does. So as long as we have a similar mechanism here, we don't need to worry about like securely separating things into namespaces and having extra objects to translate IDs.
Okay, so the object plays two roles. Its existence defines the session token. Okay, its existence is related to that, and the other part of it is we need to at least track the Kubernetes volumes involved in the setup call. The idea being
but my expectation is that the sidecar will be able to read all the Kubernetes objects it needs to be able to read to just directly extract the bits of information it needs.
All right, no problem.
Pass it down to the sidecar.
So you're saying the sidecar can translate, so not an issue.
Yeah. Because that's how all the sidecars are today, right? They are considered core pieces of Kubernetes infrastructure that just do their jobs, and they do them securely.
No problem. They're just it's just repeating the lookup, but not a big deal. Yeah, not a big deal.
Okay, to the extent that we can simplify things and remove levels of indirection that aren't strictly necessary, I think that would be good. Overall, I feel like it's a good architecture.
Okay.
Yeah, this looks really good to me. I think the fact that you have the client using RPC directly and not involving Kubernetes API server is a big improvement. I think the only sticky point here might be authentication authorization. I guess really it's that opaque token is the way that the backup client will say, yes, I am authorized to grab this data.
That is correct. Yeah.
And so I think that seems reasonable to me. What we should do is a security review with maybe SIGAuth or the security folks, just to make sure that they're okay with it. But otherwise, I think at least outside of the security bits, this looks good to me. For other folks on the call, any questions for Carl and team?
I was a couple of minutes late. Did you present the actual CSI level interface, the specific gRPCs that an SP would have to implement to make this real?
Yes.
Okay.
That would be these. There are two proposed RPCs in one service.
Right. Okay.
Yeah.
So if you're a storage vendor, all you have to do is package an extra sidecar and implement these extra RPCs, and you're done.
Yes.
Yeah, I think that's an important thing to communicate, because most of the people involved in CSI are storage vendors, and that's all they care about is, what do I have to do to make this work? The rest of it is just work for us to do the plumbing.
Yeah.
Oh, and of course, backup vendors are the other interested party here. So
yeah,
having a clear summary of, if you're a backup vendor, here's how you consume this is good.
Yeah. Yeah, there are links. I mean, I didn't show all the slides, but there are links to various different things, right? The link goes over here. There's actually a prototype which demonstrates this proposal, right? We demonstrated in the working group. The deliverables from the community thing would be the CRDs, the roles, right? The manager with the validating webhook and controller, sidecar, and then samples of how things work out. I guess samples of how to use the gRPC, etc. And the only other piece would be from the vendor. And just in terms of color coding, right? The vendor community components are this purplish color here, and the vendor components are this dark gray. So there's only one component the vendor needs to provide.
Michelle, Shing, did you have any feedback?
I'm fine with it. We have already went through this in the data protection working group. So
Cool.
in general, I think this is going towards the right direction.
Shing, do you know of any implementations of storage controllers that are likely to be able to implement this API?
Yeah, so actually we should actually try this out, just we have not got any resources to work on it. Yeah, so that's something would be good to do, is to have someone actually really implement this. But from the security point of view, I did contact CNCF security. There are some people got assigned to look at this. So maybe we can just ask them to look at the slides, maybe listen to the recording and see if they have any suggestions, concerns.
Yeah, that would be great.
I need to figure out how we can get NetApp to implement something along these lines, because as far as I know, there is nothing in NetApp's existing storage that exposes this kind of functionality. I mean, there's this
thing. Okay.
Yeah. This and it would. I know that the information is available in the device, but it's not exposed, and so it would be great if we could find a way to convince the NetApp people to actually expose it.
Yeah, so we do have those APIs. Of course, we have to try it out to find out if there's anything missing. Right? In general, this looks good to me.
Yeah.
Do we have storage vendors present who can kind of nod and say, yeah, this seems reasonable in terms of something we can implement?
I mean, from my time at NetApp, I can say like it's technically possible to implement it, but it would have to be exposed both at the operating system layer, and then there'd have to be, the CSI plugin would have to consume that API and expose it out this interface. So like a lot of work would have to be done, but I don't see why it couldn't be done. It's just a question of motivation.
Got it. Cool. All right. Thank you, Carl and team, for the presentation. Anyone else have any other questions before they go? Okay, so I think next step we can proceed with a PR on the CSI spec repo. Do you have a timeline in mind, Carl, for when you want to take this to alpha?
Well, it's not. We missed the recent deadline. I don't think we have bandwidth to address this close deadline, but probably the next deadline. I think it's when you say Shing.
Then probably 1.29, right? So I think we are too late for 1.28.
I think that's perfectly fine. So I hopefully we can get the CSI spec in maybe sooner, and then target 129 for the Kubernetes changes.
Yeah, and if you can update that cap, that would be great. The cap does not have the latest design yet.
Yeah, we'll start working on it. I think Ivan Prasad and I have talked, and Ivan's already updated the cap, the PR behind it. And so we'll get started. Yeah.
Awesome. Thank you for all the hard work on this. I know this has been a long time coming, and this looks great.
Thanks.
All right. I think we can move on to the next topic. It's from Sunny, modify volume for quality of service. Sunny, you want to talk about this one?
Yes, can someone share the PR on the screen?
Yeah, hang on, let me share my screen. All right, go for it.
Okay, so I think I'm still seeing the proposal for the previous discussion, but
Oh, Carl, are you still sharing or?
I can see it. Spec modify volume for QoS cap.
Yeah, I'm seeing her desktop, yeah.
Yeah, Sunny, make sure you're looking at the Zoom window.
the Zoom window, okay. All right, I think I'll just try to open it myself.
Sunny, let me give you permission to share. Would that help?
I think it's okay.
Okay.
Just in general, like this is the cap we have been discussed for a while, and then the upstream cap is approved, and the CSI spec change is focusing on the controller modify volume change. And there are, I believe I addressed most of the comments, but I'm just not sure like if there are any other suggestions to the change
Yeah,
in general.
So I'm in the process of trying to write some more comments around. I think we need to add verbiage specifically to the create volume call that explains the relationship between the existing parameters and the new mutable parameters. In particular, I'm thinking about backwards compatibility, because what's going to happen is there's going to be a bunch of existing CSI plugins that have parameters that are in fact mutable, but they get specified at creation time through the storage class today. And what vendors are going to want to do is they're going to want to move them from their storage class into the so-called volume attributes class. And so there might be a period of time where like the parameters are in both places. And so my thinking is we should have words that say, you know, stuff that appears in both parameters and mutable parameters, the mutable parameters should take precedence. And this should be like a should, not a must, because all of this is ultimately up to the storage vendor and how they want to do it. And it's all opaque to Kubernetes. So we don't really care at the Kubernetes layer. But I want to give people enough guidance that like as parameters get moved from storage classes into volume attribute classes, you can do the backwards compatible thing and have something that'll work on both older versions of Kubernetes and newer versions of Kubernetes and older versions of CSI plugins and newer versions of CSI plugins, so that you can ensure that you get consistent behavior across versions. So I think we need to spell out in create volume, like if a parameter is part of both parameters and mutable parameters, look at the mutable parameters. If it is in fact a mutable parameter, right? If it's an immutable parameter and it's specified, you can ignore it. But we just I'll suggest. Go ahead.
Oh, sorry. I would actually go a little further. Instead of like ignoring, I would maybe say if they're like duplicate parameters and they're say different values, I would probably error at that point.
Well, I mean, we can suggest that, but like I'm very nervous about, you know, just all of the scenarios where someone is going through an upgrade and they have some old storage classes and they're introducing new volume attribute classes and they're deprecating their parameters from the storage classes and moving I could just see all these possible situations where you're going to get two copies of the same key.
Yeah, I think two copies of the same key is fine when the values are the same, but I feel like when the values are different, I think it's better to error in that case, because then
I mean, so the wording I was going to suggest and you can tell me if this makes sense, is that specifying values in the mutable parameters map when you call create volume should be equivalent to calling create volume with an empty mutable parameters map followed by a call to modify volume with those mutable parameters specified. Like you should get that same behavior, right? And in that case, if you actually did have two different copies of the parameter with two different values, the mutable parameter would just win because it would be the same as I created the volume and then I immediately mutated it with the new mutable parameter and got that value. And I think that'll be more deterministic if we recommend that semantic that then even if you do weird things, you'll still get a usable volume. I would hate to to have a situation where your volumes couldn't be created because of some small mistake in your volume attribute class, where some parameter that didn't actually matter didn't match some other parameter that didn't actually matter.
Yeah, I mean, I guess I'm thinking about the scenario where for some reason whatsoever, maybe whoever is managing the storage class might be different than the person that is managing the volume attribute class. And just kind of like, if say someone creates a volume attribute class that conflicts with the storage class, then I think we wouldn't want, from like a permissions perspective, I think we wouldn't want, say, volume attribute class to always win out.
Yeah, but I think that's an untenable position. I think that if you look at it from the CSI or the vendor's perspective, like they're going to have to implement something that's backwards compatible, right? And so they're going to have to support the situation where the parameter could come in through the storage class or the volume attribute class just for backwards compatibility. And on the operations side, I think that you have to have the same person be managing both things. I can't imagine a reason why you'd want different people touching those two objects. I think it has to be the same person. And if you assume that, then all the permissions questions go out the window, right? So do we really think that you'd ever have a situation where this is a different role? Because it's just, there's some person like an infrastructure admin who has to deal with the storage, who has to set this stuff up. And they're going to be doing both things, I figure.
Yeah, I mean, I think in the common case, I don't expect it, but I think there has been some discussion around folks that want to be able to give sort of per PVC, want to be able to support like, per PVC control over volume attributes class.
Per PVC control over volume attributes class. Okay, but I mean, you're always going to have the option of provisioning your PVC with an empty volume attributes class, and then 10 seconds later, changing the volume attributes class, right? And if you do that, the volume attributes class will always win, I think. So I think we should just say, behave as if that's what the user had actually done.
I guess that's true. I don't think anything would prevent that from happening.
Yeah. So, okay. So I'm going to recommend some words that basically say, this is how we recommend SPs behave. I don't know if we need to require it because it's ultimately up to them to not break. But I think that's the best recommendation, to say that the mutable attributes should be applied as if they had been applied after the parameters. And SPs are welcome to ignore ones they don't understand, and to to override ones that were specified in both places with the mutable version. And that'll maximize our forward and backwards compatibility story, I think.
And the ignoring the ones they don't understand is consistent with what we're doing with params, the old params.
Well, we don't say what you're supposed to do, but the only way to be forwards compatible is to ignore ones you don't understand. So
Got it.
So I think it's a good policy in general to ignore ones you don't understand.
I guess in the past, though, I think a lot of CSI drivers error when they get an attribute that they don't understand. I think it's like, to help with like if someone typos the key, then we don't, go ahead and like provision the volume without that, without whatever the attribute they requested.
I mean, the spec certainly allows that behavior. I think if you implement that behavior, it becomes very hard to add new features, because then every time you add a new feature and someone puts it in the storage class, all the old drivers break. But maybe we don't need to say anything. Maybe we can just leave it up to vendors to do what they consider most friendly.
Yeah, I guess it's a trade-off between being flexible for backwards compatibility and allowing a migration path versus making sure that we are not, or we're giving an appropriate signal when somebody fat fingered and typoed something they didn't intend to.
Yeah, I would almost prefer a solution where like some controller just examined all your storage class and raised warnings if it saw things that looked funky, rather than failing to create volumes, right? Like send that signal through a different channel. Because failing to create volumes is a fairly serious failure mode.
Yeah, but I think it also has potentially serious consequences if if there's like a typo, right? If someone say intends to enable encryption or some extra security mode and they haven't typo it, if we go ahead and create the volume, that will cause like, serious policy violations and things.
Yeah, I mean, I can see that. I mean, I guess at the CSI layer, we shouldn't have too much of an opinion, right? Because we're saying it's opaque. So that means it's up to the vendor.
And I guess if a vendor wants to play it safe and return an error for keys they don't understand or values that don't make sense, then do they have is there a valid migration path?
You would just have to make sure you upgrade your software before making changes to your YAML always, right? You just have to order your upgrades carefully.
Yeah, so I think maybe just leaving it up to the SP to decide maybe the best way to move forward here instead of making a recommendation one way or the other.
But specifically about the interaction between the two maps, I think we can make a recommendation there and say
Agreed.
behave
Yeah,
as
that
if,
one I think is okay. Having immutable override mutable seems reasonable.
no, the reverse. The mutable ones override the
Yes.
parameters.
Yeah, right.
Okay, so any other questions?
I mean, I think fortunately this is a fairly simple change at the CSI spec level. So as long as we get all these words, clear, there's not that much to argue about. And I think it should be an easy change.
Okay, good. Then
So,
I will wait for your review and then update the PR again. I think there is another person supposed to review, but I don't think he did.
What is the state of the sidecar implementation that will use this? Do we have a prototype yet? Do we have any code that would exercise this that's already written? Okay.
No.
So is the thinking that there would be a whole new sidecar that would just exercise this one API, or that we would extend the existing provisioner sidecar to do this job of watching PVCs and their volume attributes classes and calling the modify?
We're thinking about using the external resizer.
External resizer. Ah.
Yeah.
Okay. I can see why that is an attractive place to put it.
It would be both. It would be both, right? The provisioner needs to handle the create volume.
Create volume. Yeah.
Oh, right. Yeah. The provisioner has to do the create, but like you could put the modify volume call in any sidecar or its own sidecar. So
Are we going to rename external resizer to something else?
I'm a bit too lazy to do that.
I mean, I guess one problem I see with that is if there is an SP that doesn't implement volume resize, but they do want to implement volume mutation, then they're going to be forced to deliver the sidecar that they're not currently forced to deliver.
I think that's fine. That's true of any of the other sidecars too, right?
Well, but I thought the whole point of splitting apart the sidecars was that vendors would only ship the ones that mattered and leave out the ones that didn't matter. Otherwise, we would just have one omnibus sidecar that did everything, and we'd only deliver that, right?
I think after after managing multiple various CSI drivers for the last couple of years, I definitely am on board to going back to like a mono sidecar model. It's just kind of like right now trying to distribute the release process across like the 5 or 6 different sidecars, and keeping track of all the versions and compatibility and stuff has been difficult.
Mauricio is actually looking at unifying all of the sidecars. We have an old issue that's been there. I think he said he's going to look at that again.
Well, if we're going down that path, then maybe it does make sense to actually put this in the provisioner sidecar, because that's sort of the oldest and most important one. And if there's any kind of a unification, it'll probably be everything collapsing onto that one, right? And given that we have to modify the external provisioner anyways for create volume, we could just put everything in for provisioner sidecar and have it do this too.
Yeah, I think it depends really on how much traction we get on this mono sidecar effort. It's something we've talked about that we want to explore, but I don't know if we're in a state yet to really make some decisions on that.
Didn't Portworx do a presentation like years ago where they had already built a mono sidecar?
Yeah, I think so.
The issue that Mauricio is looking at has that reference to the Louis proposed that one, right, a long time ago.
It was Louis.
Yeah. That issue has everything in there. So.
Okay. So we have the history.
Yeah. I think definitely if we actually want to pursue this, I think putting together like a mini design about it would be useful, especially things like how to handle the fact that every sidecar has like 10 different command line flags.
Yeah, it definitely is getting very complicated.
Yeah, and we would have to have some migration path for vendors, right?
But I would just the only thing is that then when we are releasing new features, it's going to be challenging, I guess.
Well, no, I think we would say like, okay, the existing sidecars are supported for security fixes only for, X amount of time. And all the new features are going into the new mono sidecar, and vendors have to just move at some point if they want the new features, right? We couldn't stop supporting the old ones.
Yeah, I'm just saying like right now we so for example, right, like snapshot, right, we are kind of really late on cutting that because of this new feature, the working group snapshot feature. But if we are having everything together, then we probably need to have a model similar to the Kubernetes, the in-tree KK model. We need to release all the new features together or move to the next release or something like that.
Yeah.
No,
Oh yeah,
right now,
and
yeah.
And
There'll be
things
a
like
lot
feature
more-
gates and other things.
a lot more bug fix releases and
Yeah.
security updates. Okay, well, my vote is for this to go into external provisioner sidecar. If it ends up going into resizer, I won't be mad. It makes sense. But yeah, I guess, do we have the fully fleshed out spec of what a volume attributes class is going to look like? And does everyone agree that that's the correct name? Or is that still up for debate?
I don't think that's for debate.
Okay, the volume attributes class is the name.
Yeah.
Awesome. I'll have to go look at that KEP again and see exactly what they look like.
Okay, I think that's all I want to discuss.
Thanks, Sunny.
Yeah, thank you.
All right, cool. So I think next step, go ahead and Ben, propose your changes, and Sunny, feel free to update your spec. And then once you've done that, poke us again, and we can try to finalize and get it merged. Hopefully, we can get James to take a look as well. His feedback's always.
Oh yes, yes. I had wanted James to be here, or at least to have looked at the.
Yeah, hopefully we can get him to review it offline. I know his calendar is fairly busy, so. But if you can take a look offline, that'd be great.
I tried to ping him on Slack, but
no response. We can help you get in touch with him via email. Reach out to Ben and myself, and we can help you do that.
Okay.
Okay, so anything else anyone wants to discuss today? All right, thanks a lot, folks. Great discussion.
Thank you.
Thank you.
Bye.
Thank you.